Do you see my screen? Do you hear me?
Yeah, we could hear you. We can see the slides.
Okay. Yes, thank you very much for possibility to present our preliminary research result. I think time is very long for this session. Hence, I'll try to present our result shortly. Our talk dedicated to problem of comparativist for big safety and decision of such problem, or maybe not decision about formulation of this problem for based on nuclear power plant based experience. My colleagues Mikhail Yastrебенецкий and me, we would like to present our result in this area. We represent National Aerospace University HAI and State Scientific and Technical Center for Nuclear and Radiation Safety. Okay. Outline of our presentation. We will talk about concept of big safety. It is not first presentation dedicated to big safety, but we need to introduce, to remember about this issue and difference between safety and big safety. What does it mean? What does it mean? 10 bigs which characterize concept of big safety and so on. And second part will dedicate it to problem of comparativistic for safety and big safety based on our nuclear power plant based experience, our work in area instrumentation control system regulation, development, research, and certification. Okay. Reasons of this research topic is the following. We work in area nuclear power plant and aerospace instrumentation, control, safety and security the last 20 years. And these two different critical domains are very different, but there are some close problem and close decision. Second reason is we investigate space system accidents and the reasons of accident crashes for last 50 years. Hence, we have information to compare with other area. Pandemic time and Russian aggression and the war for the Ukrainian independency and the capture of Chernobyl and Zaporizhia nuclear power plants is additional very important reason for these topics. And what about any models to take into account this issue? Today, Professor Sergei Sauk talk about military issues, and our task now is more simple because a few presentation were dedicated to this task as well. Our research, our analysis based on 3+ sources. First one is the 2 books on nuclear power plants instrumentation, control, safety and security, which were published in the United States in 2014 and 2020. Next one, a few publications in journal Space Science and Technology and Nuclear and Radiation Safety, dedicated to comparing of these two domains, nuclear and space. And 2-3 years ago, we published our first paper on problem of big safety as crossing different types of safety and security, not only for instrumentation control and for in more issue. And one more sources for our report is Hegel. George Wilhelm Friedrich Hegel helped us due to his fundamentals in area philosophy. For example, in his famous book on dialectics, law negation of negation, principles, thesis, antithesis, synthesis, and so on. And so, very shortly about big safety, security. Why big? We talk about a few different issues of safety and security, or bezpeka in Ukrainian. Functional safety, information or cyber security, physical IT security, internet safety, safety and labor protection, and so on. We understand what does it mean, all these safety and security sides of big attributes, and it is very important to understand how we can take into account different issues for assessment indicators of such safety critical system as reactor trip system for NPP, board control system for aviation, and so on. One of the general models based on understanding what is the difference between safety in security. When we talk about safety, we talk about influence of instrumentation and control system on environment. If you talk about security, we need to take into account influence of environments to system. And general model join these two issues. We can decompose all these aspects, take into account physical influence, influence of information environment, influence on the different aspects of security, such as integrity, availability or accessibility, confidentiality, and so on. And this general model allows understanding all scenarios, all combination, influence, attacks, failures, and so on to explain, to evaluate indicators of safety and security. When we talk about big safety and security, we talk about three main issues: functional, cyber safety, information cyber security, and physical IT security. Considering three parameters: physical, information, and functional. At the level of operation technology, level of information technology, level of physical technology. This scheme explains aspect of different kind of safety and security, considering nuclear power plants. If you talk about nuclear power plants, the top attributes is nuclear safety, nuclear and radiation safety. Other attributes are attributes of second level, and there is relationship between these attributes which we need to take into account. Additional maybe some strange attributes is infection safety. We talk about this one because during 2 years we lived in a condition of COVID, and we analyze how this kind of safety, infection safety, can influence into other part of big safety, such as functional, information, fire, and so on. Additional issue is military safety. Professor Sergei Saukh talked about this issue. It's really very difficult in point of view how we can assess this issue, how we can formally describe this issue. But now we understand, and that is a very hot topic, very important point for specialists on safety, not only technical safety. Okay, go ahead and talk about big. We suggested 10 big features for big safety. They are based on big or complex system, big or complex environment, big or complex properties or attributes. There are a lot of different issues concerning attribute of safety. Big value of failure, big number of reasons, big data, big requirements, big time and process complexity of development, implementation, and so on. Big toolbox set of technique and tools for safety assessment and assurance, and huge resources for assurance and recovery. Two options we have here, two issues we have here. It's the influence of modern information technology, such as IoT, big data, artificial intelligence, augmented reality, and so on these attributes of big safety. And COVID, and of course the war influence on these attributes as well, and we need to understand how we can take into account this issue. It's the result of our analysis how we can provide big safety taking for different types of big safety and different well-known methods for providing of safety, such as redundancy, diversity, defense in depth, reserves of resistance, independent verification, validation, platform-based decision, and so on. We analyze application D3 approach, defense in depth and diversity, as two part of process to protect assets, physical and information assets, from activity, from influence of different kind of threats caused by physical and information influence into such kind of system. And now I'll talk about very interesting and favorite example for our research is aspect diversity. According with requirement to, for example, a reactor trip system, such system consists of two systems, main system and diverse system, which can have the same structure. For example, 2 out of 3 or 2 out of 4 as first cascade, and second one 1 out of 2 cascade. Main system and diverse system are based on the different software, different hardware platform, different teams who participated in development testing and so on. There are standards which formulate fixed types of diversity. It's the standards 7007 NUREC, well known in nuclear power plant domain. And the question is the following: how we can analyze such system in point of view philosophy of evolution, in point of view philosophy of comparativistic different safety critical domains. First step, we down a lot of years ago, and we analyzed evolution of reactor trip systems, which based on two version structure, similar this scheme. When we have main and diverse system, and task is how we can provide realization of the same functions by using different diverse decision. Hence, our analysis of evolution reactor trip system diversity was based on the application law negation of negation, and we remembered about Hegel formula: thesis, antithesis, synthesis. And during our research, we saw that there are a few cycle of development to version reactor trip system in nuclear power plants. Beginning of application hardware and hardware subsystem. We have main and diverse system as in 1980 years as two hardware based decision. Next point was application microprocessor or software based decision. Next one, complete digitalization of decision, which based on one kind of software and microprocessor, and second type of software and microprocessor. And next step was connected with application FPGA technology for such system, and step by step we got a second cycle of this moving based on Hegel formula, thesis, antithesis, synthesis. After analysis of application diversity approach in different domains, we compare. We tried compare two kind of system. It's a board control system for Airbus 340 and 380, most complex system, and reactor trip system of nuclear power plants based on software, hardware, and FPGA based diversity. And you see these two different systems, reactor trip systems, two version systems, system, and flight control system, onboard control system, which consists of 10 channels, 10 channels which decompose into 5 duplicated subsystems, and three of them is the first version, and the second one is the other diverse version based on different software, different operation systems. Hence, in this case, we have software diversity plus hardware diversity, because duplicated subsystems are based on different processors and different printed circuit board. Hence, question is how we can use, how we can compare this decision, and how we can use benefits of one of them to improve safety indicators to other one. How we can do it, make it considering requirements to this system. It is a question we have not complete answer, but we would like to talk about this issue to invite researchers, to invite PhD students to go ahead with decision of such problem. And conclusion. The problem of big safety becomes global one because we have causes and consequences. Cannot be predicted and warned about outside the global context, and it cannot be solved by a single organization, region, or country. Consequences cannot be dealt with by local efforts. And we talk about global organization technical platform based on the big safety concept, with global support, with global team, and so on. This conclusion was made before the hot stage of the Russian aggression. But now this conclusion is more important in our opinion. I thought about the problem of influence of coronavirus pandemic. We could talk about this issue as a black swan problem. However, for us now is more important problem of the war, the military attributes and influence military issue on the safety problem, nuclear power plants. First of all, I think this problem is important and hot for small module reactors because it is a safety critical object as well. And we would like to invite all specialists in area safety and security to join force. And Comparatvistics is one of the principles to share best practice, and it's a mechanism for the center's terminal development, theory, and practice of big safety. Thank you very much for your attention, and any question and comments, please. Thank you.
Yeah, thanks again, Vyacheslav, for your presentation. Mr. Mikhail, colleagues, do you have question, comments? Yeah, Sergey, please. Yeah, Sergey, please go ahead.
The concept of big safety, does it possible to apply this concept to the social system?
Very good question. Thank you. Now we are thinking about humanity issue of big safety, starting from people, just for people, for individual safety. Because if you talk about people, we can suggest similar model, big safety, because we have influence information, physical for us. Yes, hence is the first step, and second one, it's an analysis of this issue for society, for more big, more complex object as well. We are finishing our book on big safety to publish in one of the editor company. We fixed just technical issue, not human issue of this problem.
And the second question about the small model reactors. When we talk about the big reactors, the nuclear power plants, we understand that this object is situated far from the big city, from the concentration of the population in the country, and it's one problem. It's a technical problem, but in the future, install the small model reactor in the big cities such as Kyiv, Kharkov, Dnipro, Odessa, Lviv. It's a problem, not only technical but social also. And what can you say about the future possibility of apply this concept in this our future of the small modular reactors?
This is a difficult question. I think I have not accurate answer. Maybe Professor S3.2 can help me. And I think small modular reactor, it is not that the problem of big safety will solve for small modular reactor. I think for small modular reactor, problem of safety will big as well, because really in this case we have some risks. Answer maybe based on understanding of concept of acceptable risk, but who will formulate acceptable level of acceptable? What does it mean? Acceptable.
I agree.
I think in this case we need analyze and predict consequences of some accidents and minimize the risk of such accident. My question, my answer, I think very wide.
Thank you.
Thank you.
Yeah, we have one more question. Tatiana, please.
I have question about big safety. No, I understood it more than better, but about advantages of big safety and about balance between efficiency and safety. In aviation, ICAO has balance between efficiency, economical advantages, and safety. I see 10 answer why big, but balance between economical advantages. If aircraft will be stand on aerodrome, this is a big safety, but job working, I think maybe must be regression analysis and forecasting on 1-2 years of safety and control and regulation of safety and efficiency. Innovation here.
I think your question is very wide and consists of a few different parts. If you talk about, for example, safety of board control system, we understand framework of this task, yes? And in this case, we can calculate, for example, availability function, reliability function, and so on. And we can calculate the value which we need to pay to provide such level of safety or reliability. Yes, if you talk about nuclear reactor, assessment of value is more complex.
I am sorry.
Voice.
Please, I'm sorry. Close your presentation because back link with microphone, okay. And it is difficult to hear your answer.
Sorry. Now it's okay.
No. Voice.
Okay, you talk about efficiency in context of big safety. I think it's a very difficult question, and I don't sure that such question has answer. How we can assess accident similar to Chernobyl, and how we can we can calculate cost to build sarcophag and any other protected means. I think when we talk about such critical objects, we need to talk about probability, about risk, because assess consequences, it is not enough correct task. as well. It's my opinion.
Do you have level of safety? Because risk has level.
Yes, of course. There are scale of safety level for nuclear and other critical object according with standards such as 61508, safety integrity level, you know, from 1 to 4, and for automotive system as well, standards 60 to 66, 26, 26.2. Sorry, there is a scale for such kind of object. Hence, it is a question related to formulation of standards as document which join different opinion, different experience, and so on.
Thank you. I agree.
Thank you.
Yeah, we have one more question. Dmitry, please.
Yes, I have. Vyacheslav Sergeyevich, you were talking about infection safety or infection security?
It's good question, because in Ukrainian language we have just one word, безпека, or безпечность, так? And we can use, for example, функційна безпечність, або інформаційна безпечність, або фізична безпечність. And we understand what does it mean. In English we have two different
Yes.
words, safety and security. And we in the literature we meet with different understanding safety and security as well. I think in infection safety, if we talk about influence on the technical issue, as we demonstrated in our scheme, this is safety. If we talk about our health, it may be security.
Yes.
It depends on very tонкий. It is accent of what does it mean safety and security.
Yes, I agree. Thank you so much.
Welcome.
Okay. Colleagues, any other question and comments? Vyacheslav, let me ask you a question about that.
Of course, you
Yes. No, very simple. Yeah, very simple. It's a very great presentation. I mean, it's a new approach to like some kind of how we can solve existing problems, right? But for me, it's like constant fighting between two mental concepts. Concept number one, it's like people thinking, think big or think small, right? In your approach, we're trying to say, okay, think big and try to incorporate all of the possible ways, all of the possible types of safety and security and the big umbrella definition, which we named as a big safety. But I have a question about that. Thinking about main shareholders, I mean, people like who us, researcher, operators of nuclear power plants, regulators, and other people who are dealing with the safety. I call them like shareholders, right? They have some kind of interest in such research. Could you elaborate what kind of benefit they might have based on your approach? So what kind of practical benefits they will have about that? Because it's a new way of looking at the old things, right? How they will benefit these people, like, as I mentioned, operators, like people, regulators, whatever, how they will benefit from your results? Could you elaborate some ideas on that?
Thank you for your question. My answer consists of two points. First one, we need remember about different influence into safety of technical point of view technical issue. Hence, this result can be used by regulators first of all to one more analyze different aspects of influence into traditional safety. Analyze is or not cumulative negative synergy of influence different attributes of safety. I think regulators is the first one of customers who can who could apply this approach. And second message of our presentation is it is let's more deeply analyze best practice and the negative practice from different safety critical domains. Professor S3.2 suggests to talk about центростремительная relation to safety, because if you talk about space domain, then we can ask space related engineers and so on. Do you anything about problem of safety in energy or in nuclear or not, and vice versa? And we suggest to accumulate best practice in different critical domain. By the way, we finished a big Horizon 2020 project on multi-sectoral security. And the idea of this project was dedicated to analyze of best practice in different domains, more in security, to understand how this practice can share in other domains. Hence, of course, we need to go ahead to make this idea, this concept more practicable. It will be the next steps of our research and development. Thank you.
Okay, thanks. Thanks for your comments, response. So, colleagues, if we don't have any other questions and comments, basically we reached to the end of our workshop.